Hi everyone, we're going to talk about wavelength selectors in this video. And just as a reminder, here is where the wavelength selector belongs in a single beam instrument. You could use a filter as a wavelength selector if you just wanted to select one wavelength or a single wavelength. But more commonly, you'll see a monochromator being used because that allows you to select more than one wavelength. So let's spend our time talking about the monochromator. Every monochromator has three components. There's an entrance slit, a dispersing medium, and an exit slit. The dispersing medium is going to be probably a prism or a diffraction grating, and believe it or not, prisms are more expensive than diffraction gratings. Let's take a look at the prism monochromator. Again, your three components, entrance slit, dispersing element, and exit slit, and we've added the light source here just to show how it works. So white light is being emitted by our source and it enters the monochromator where it strikes the prism. When it strikes the prism, refraction occurs, which, as you can see here, is the bending of light as it passes from one medium, the medium of air, to another, the medium of the prism. Refraction, again, the bending of light as it passes from one medium to another, and as you can see in our diagram, different wavelengths are bent at different angles. So when the light leaves the prism, refraction occurs again, and in this example you can see only the purple radiation makes it through the exit slit. These other wavelengths or colors remain inside the monochromator. And if you wanted to change the wavelength, you would have to rotate the prism. So that was the prism monochromator. Let's take a look at a monochromator that uses a diffraction grating. Again, look at those three elements: entrance slit, dispersing element, and exit slit. So now we're using a diffraction grating, which is just a shiny, highly grooved surface. So how does this work? Well, we have our white light, it enters the monochromator, and notice how those rays are unparalleled. The purpose of this first collimating mirror is to make that radiation parallel, and then it strikes the diffraction grating. You can see all these different grooves. Sometimes those grooves are called blazes or a blaze, and at every groove, diffraction occurs. Here you can see it happening here. Notice how we've gone from white light to separated radiation, and actually diffraction occurs at every single blaze. I'm only showing it again in two places just to make the diagram simple. So we've got our radiation separated into the different wavelengths. What happens at that next collimating mirror? Well, it focuses the radiation onto the exit slit. And you can see now that the red radiation leaves the monochromator while this purple radiation stays behind. So again, if you wanted the purple radiation to leave the monochromator, you would have to rotate the grating in order to change the wavelength. So that was an introduction to monochromators. In the next video, I want to talk a little bit more about this process of diffraction. Thanks for listening.